So welcome everyone, good morning. Great to see a nice turnout here in Canberra for the OpenStack Day. Alex and I have had the privilege of being able to present at many different OpenStack summits and OpenStack days around the world. So we feel very, very privileged to be able to do that. I'm also very privileged to be able to work with my colleague Alex Tesch. He's been involved in OpenStack for quite some time now, since the early Grizzly days. Myself, a little bit shorter, probably most of my involvement from Icehouse onwards. Alex recently just back from Barcelona, so where he was presenting over there, and we both presented over in Austin earlier in the year as well. So we really do enjoy getting involved with the OpenStack community, as Mr. Flanders alluded to earlier. Please feel free to come and see us. We do have a small booth over in the corner there where Alex and I will be around. We're also presenting later this afternoon as well in the non-technical track. So we're presenting in both tracks today. But please come and see us. We've got a number of customers in Australia and New Zealand, and we'll actually be talking about them and their use cases this afternoon in the non-tech track side. So by all means, come see us, have a chat about those use cases. Many of those customers are from the banking industry as well. So in terms of security concerns and some of the hardening that we've had to do in order to be able to get banks onto it, quite similar in terms of the security profiles of some of our government customers too. So definitely come and have a chat to Alex and I, and we can help you out with that. So today we're pretty time poor. Pretty time poor today, so I better shut up and get on with it, I guess. We're going to take you through two major use cases today. And the first one, we're going to basically stand up very quickly an Oracle backend with two web servers sitting in front of it. We will be using LBAS v2, so our distribution does run on load balancer v2, which is Octavia based. So we'll be utilising that. Many of our customers that we'll be speaking about this afternoon, that's been a real kicker in terms of being able to do self-healing and proactive scaling. Especially in the banking industry, that's been something that's been of real interest in the last 3 or 4 months, and probably some of the biggest driver that we've had. So basically doing autoscaling from heap, utilising LBAS v2. And our latest distribution that we'll be demoing on is Mitaka based. So it's our Helion OpenStack Mitaka based. And all of it will be executed from heap. So we'll get Alex up in a second just to kick that one off. But what we do want you to remember is that the majority of our customers are integrating into continuous delivery rigs. So we get, and the later demonstration that we'll quickly cover off, which is based around Selenium auto testing. So we're getting a lot of test-driven development use cases with customers coming to us and wanting to understand more about how to integrate with existing Jenkins pipelines, Atlassian Bamboo pipelines, Hudson, et cetera, and really tying into those. So please keep in mind that the majority of these use cases are being kicked off, not really by people, but generally on code check-in, and also in terms of continuous delivery rigs executing that as well. Without further ado, I'm going to introduce my esteemed colleague, Alex Tesch, to kick us off. Thanks, Alex.
Hi, everyone. Can I see a short of hands how many of you guys were in the Sydney OpenStack Day? Okay, not that many. Well, actually, the original plan was to have the first demo already running so that you guys can focus more on the second one, since the first one we presented already in Sydney Day. But Anthony disagreed a bit with that approach, so we're going to run everything from scratch, which is twice the risk. We'll make it more fun, right? All right, guys, this is what I call the production tenant. Okay, this is basically my Heat admin account, and from here we can see that at the moment we don't have anything running. What I will do is, let me go to the network topology. It should be pretty much empty. And I have this transparent console here, which is going to help me to trigger the script. And hopefully what we will see in a few seconds is that we are going to stand up what we call a mission critical environment. Okay, this environment is going to consist of 2 Tomcat web servers. In this case, we have an Oracle database in the backend, a real Oracle database, which is making use of a cinder volume to store all the data files, control files, redo logs, and also archives, so you can actually take backups of the database and put it in backup mode, which is going to be very handy for the second use case. And on top of that, we have a load balancer, okay, which basically does what it does, right? Load balance between the two Tomcat servers that we have in front. So right now we can see that the networks are starting to come up. We have one called DMset. The load balancers are going to be sitting there. We have our database network. And one of the cool features that we have in the load balancers is that we use a driver called Octavia. Any of you guys are aware of what Octavia does? All right, Octavia is pretty much a new approach that we are taking in LBAS since version 2. Load balancer as a service used to be based in kernel namespaces, and it has a few drawbacks when it comes to failover. So pretty much the moment that your infrastructure, one of the compute nodes dies, your kernel namespace is gone. So you won't have any redundancy for the load balancers. So with Octavia, what we are doing is we are actually getting an actual virtual machine running in the computes, and we are going to create several of them, several instances of the load balancer. And they are going to be monitored among themselves. They will know when one of them goes down, there will be more taking over. So we are kind of achieving what we call an enterprise-grade load balancer inside OpenStack. All right, you can think of it as a VNF, okay, driven from the OpenStack community, which is quite cool. All right, at the moment we can see from the script, the stack was pretty much triggered. Now we are creating the load balancer pools. All of this at this moment is being driven by Ansible, okay? There are several ways in which we can orchestrate in an OpenStack environment. The orchestration template is one of them, which is part of this demo as well. If we quickly take a look to the stack tab, we should be able to see that the stack was pretty much completed, okay? So it's a bit messy because of all the components that we have. Let's jump into the compute, and we should be able to see the two web servers and the database in the backend. And obviously, this database is being backed up by a cinder volume, all right? So while this one finished running the script, let me show you pretty much at a high level what we are trying to achieve. Okay, on the left side, we have our production tenant, right? Pretty much what we explained, the load balancers, web servers, the database in the backend. And on the right-hand side, we have a developer tenant. So, like Anthony said, everything driven from CI/CD. The dream for a developer is basically to conduct tests with real-time data, okay, as close to production as possible. So for our second use case, what we will do is pretty much I will show you that this second tenant that we have is empty. There is nothing running on it. So what I will do is from a script, everything driven from Ansible, all right, and scripting, we are going to clone the production database, create a clone of that cinder volume. We're going to transfer the volume into the development tenant. And finally, we're going to stand up a new environment, which is going to be used by this developer to basically conduct tests live with production data. Okay, let's take a look at our script quickly. Hopefully production should be up. Okay, this is the IP address that we use for our load balancer. This is kind of our enterprise application, and what you can see here on the left side is pretty much coming from the Oracle database, all right? All these fields. So to make the test a little bit more interesting, what I will do is let me log into the production database, and I will start running some queries. So I will do all the cloning and transferring to development while we are running queries live in production.
And just to sort of add a little bit more to that context while Alex is setting that up, the customer that came to us that wanted this particular use case, they wanted to have it so that they could clone that production environment across into a dev environment using continuous integration methodology, but also whilst with no downtime whilst there was reads going on that database. So what Alex is going to prove to you here is that in the background you're going to see a massive select query which is happening, running in the background while we clone it and then move it across to the dev tenant ready to be used, so they can use, at this stage, some live data. In this particular case, the customer then ran some wash ETL across the top of it to desensitize the data.
Right, this is our production database. The instance is currently running, and what I will do is I'm going to just quickly run this query script, which is going to create a few loops of queries in the background. Okay, this is going to run for quite a while. Actually, I may need to stop it. So while this one is going, and we will see it in the background, hopefully, I will quickly go to my next use case, which is the database cloning. Okay, what the script is doing at this moment is I am actually connecting to the production database and I am quiescing the database. So for those of you familiar with Oracle, quiescing is pretty much putting the database in backup mode. As you can see, the queries still go on, but the database is sort of holding all the commits so that we can get a consistent state and we can actually take a snapshot of Cinder. Okay, the snapshot is a very quick thing. Within a few seconds, we will get a snapshot. Actually, it happened already, snapshot created. And after we have the snapshot, we can pretty much release the database. Okay, at this moment, when I release the database is already committing transactions, okay? And what I will do at this time, because we pretty much proved that we were doing the cloning and everything with the database running, is I'm going to stop my query because all of this is running on my machine and it's kind of getting slow at the moment. So let me slow down this one. Let me close it. And now, while the volume is creating, let me go to the development tenant.
So Alex is basically going to log out of production and we'll come across into the development tenant and we should start to see all of this database and everything start to be there so that we can then create a development environment which literally replicates production via code.
Really slow at that one. Let me just... Cool. All right, this is still production. So I will go to my volumes. We can see that there is actually a clone being created at the moment. And eventually this clone volume is going to get transferred to my development. So what I will do is, let me quickly sign out from production. Let's go to dev-admin, which is my tenant administrator. And at this time, if I am quick enough, we shouldn't be able to see any volumes. There is nothing here. There are no instances, no volumes yet. All right, so the environment is pretty much empty. So one of the things that Anthony mentioned before is that the moment that you place your critical infrastructure inside OpenStack, everything can be driven by code. And this is what we're trying to demonstrate, right? For an Oracle DBA and for system administrators in the past to perform this exercise, it was quite tedious, right? And there was a lot of manual processes that they need to follow, and they were prone to errors. In this particular case, pretty much just using Ansible, a few scripts, and leveraging on Git to stand up the developer environment once the database is cloned, you can get it done within 4 or 5 minutes. All right, so that's one of the key differentiators here, right? And that's one of the advantages that you will get once you start leveraging on OpenStack in creative ways. Okay, so at this moment, I am cleaning up production, so I am deleting the volume that we have in the other environment. And after the volume is deleted, we should be seeing the transfer from the clone volume from production to development. Anthony, do you want to talk a bit about the rigs that we can actually use to leverage on the scenario using Jenkins? And we have a pretty cool use case that we will be showing later in the booth. And Anthony did a fantastic job with Jenkins and Selenium.
Yeah, sure. So just while this one's completing, because we're not going to have time to run through our second demonstration today, but we do have one third, actually, sorry. Third demonstration. But the other part of this puzzle, so once obviously the data has been replicated, what we also have is the ability through heat orchestration to stand up test automation. And basically what happens is the next step, which we won't be showing you all of that today, but please come and have a chat to us a little bit later and we can show you some of the code and demo some of it. But what we then do is on top of OpenStack, we go and stand up a Selenium hub. And then a number of Selenium nodes. So you can stand up nodes to be able to do Firefox-based testing or Apple iPhone testing or Android testing or whatever it might require. And then, of course, inject your test cases. In this particular case, the company that we were working with to develop this put together about 2,500 test cases that they run. And, of course, they need regular production-based data to be able to run that on a weekly basis because they have an internal goal that they'll never deploy into production, and they have semi-automation through to production for their deployment rig, but they'll never actually deploy into production until they've had 2 stress and volume tests that have automatically run against a production log of data. And that ensures that the quality of their code is up to scratch and that the performance that they're getting is also up to scratch too.
Thank you. All right, guys, we can see from here that the Oracle clone volume was already transferred, okay, as part of the scripts. And at this stage, actually our hit template should be kicking in so that we start to stand up the environment. So this one is a lot simpler than the other one. It's just only one instance, which is going to be our database. So I believe that it's actually up and running at the moment. So in the customer environment, what we did was actually attach development to what we call a provider network. Okay, so the developers, they have their own network that they use to conduct the test. In this particular situation, we are pretty much attaching to external one, so we will be assigning a floating IP later on. And the last stage of the test is pretty much to connect to the development database and run a query and make sure that it's an exact copy of production. All right, so perhaps just give me a few more seconds while this one finishes running, and we should have a positive outcome, hopefully. All right, just to give you a few more information before we finish the demo, all the scripts that we are using today are pretty much in our GitHub repository. So for those of you guys who are keen to give it a try and see how this was done, if you want, you can take a picture.
Or just come and see us later and we'll tell you where the GitHub is. But all of our demonstrations that we do, we always push them into our GitHub repository and share with everyone.
This is the one. Okay, the volume was already attached to the instance. Oops.
Oops is never good with a live demo.
Yeah, it's never good. Let's see what happened here. All right, the volume is there. We actually have the data. There is an Oracle process running. I think it could be a false alarm. Let's log into Oracle. No. It's connecting. And the instance is open. Let's see if we have our table space for the production tenant. Guys, the scheme
That
is
works.
there. Let's run some transaction. Let's just run a quick query and make sure that we have more or less the same information that we have in production. I think we do. Sale and rent. Let's go back to this guy. Sale and rent. All right, so this is an exact clone of the production database, right, which we achieve in about 4 to 5 minutes. Well, guys, this is the only 2 use cases that we have for today, but like I said, we have Jenkins and Selenium running in the boot. If you are keen to go and take a look, please feel free to do so. Thank you so much.
Thank you. So I think we've got about 2 minutes for questions, if that.
Yeah, absolutely. Definitely. And once again, I'd love that these guys do demos. If you ever come to the summit, I think there is kind of a pride in making sure that you get up and show what you do. So really noble effort, and everybody knows how stressful it is to do a demo. So a brilliant job. Any questions?
Thank you.
Baffle, yes, sir.
Is the migration actually part of the OpenStack API? Is what you use to migrate Oracle, can that be applied to other databases? Or?
Good question. Yes, it can be applied to any database. So what is part of OpenStack and the APIs that you are using is pretty much based on the Cinder project. So the cloning of the volume and before the cloning, actually the snapshot that we're taking, all of that can be driven from OpenStack APIs. The part that OpenStack cannot handle at the moment is anything that is related to the database engine itself. So obviously before creating a snapshot of the volume followed by the cloning, we will need to quiet the database. And this is the portion which Ansible will become handy, or some scripting, and that's why you can see that in the demo we basically just run a master script, and the script either calls Ansible or Oracle scripts or hit at the end to stand up the other environment. But that portion related to the database engine is the one that OpenStack is not fully aware. It can be automated, but not as part of the OpenStack. Now, going back to that point, we have some partnership in place with Tesora. Tesora is perhaps the major contributor today to Trove, and Trove is a project that does database as a service. In this particular use case, we are not making use of Trove, so pretty much we have cooked images for Oracle, and that's what we're doing. And the scripts are actually inside these images, so when I call the scripts, they are pretty much you're connecting through a tunnel to the instance to get the backup mode triggered and then proceed to take the snapshots. But Trove is doing a lot of work on that area, and they have their own images that can be leveraged, and one of the key advantages is tomorrow when you want to upgrade from, let's say, Oracle 11 to 12c, you don't need a DBA because Tesora is doing that job for you. Tesora today is fully integrated with Helium OpenStack as well. So if you guys are keen to ask for more questions related to this partnership, please feel free to do so. We will be in the booth.
One really important thing to take note is all of these different OpenStack projects. If you're wondering how mature they are, you can just go online and look up OpenStack project maturity. And absolutely Trove. I don't know if you guys were able to go to any of the Trove sessions in Barcelona, but they really have upped their game. And I'm pretty sure they're quite high on the software, on the maturity. So from this time last year where everybody was like, Trove, I don't know. Now everybody's like, oh, Trove, maybe, So definitely have a look at that. Time for one last quick question, if anyone has a quick question. Otherwise, if you'll please just join me one more time in thanking them both, Anthony and Alex. Thank you so much.